This video is a lesson in scientific notation. It accompanies the organizer that is on page 109 of your binder. So take a moment, if you don't already have that pulled out, and pull that organizer out. We're going to simplify the idea of scientific notation and everything that's on the page a little bit for you. So we're not going to actually go through everything on this page, but we'll do some examples to hopefully drive the idea home for you. All right, so scientific notation is really just a shortcut way of expressing really big or really small numbers. So you're used to seeing scientific notation, something like this. 3.2 times 10 to the negative third is an example of scientific notation. Well, it consists of two parts. So I call it the decimal part and the exponential part. So the decimal part is the number to the left of the times. The exponential part, obviously, is the 10 to the some sort of power on the right side of the times. And then, obviously, the times connects the two. So normally, we've got a number. Let's say we want to go from a normal number to scientific notation. So you've got something like this that we want to write in scientific notation. One thing that you might want to remember is that any number that you look at could be expressed in exponential notation, not scientific notation. Exponential notation by writing times 10 to the 0. Okay, there's a number in exponential notation. It's not proper scientific notation because to do proper scientific notation, you want one digit and one digit only, not 0, to the left of the decimal point. So to put this in proper scientific notation, I am going to make the decimal part 5.2 because I want one digit to the left of the decimal point. Now, in order to go from this number that I wrote out to scientific notation, I took the decimal point, which hopefully you remember is typically there at the end, and I moved it 1, 2, 3, 4, 5, 6 spaces. Okay? I moved it so that I made the decimal number look smaller. To figure out what I'm doing to the exponent, I simply need to remember that whatever I did to the decimal part, I do the opposite to the exponent part. So I made the decimal part look smaller. Therefore, I want to make this exponent part look bigger by the same number. So I made it look smaller by 6. I'm going to make the exponent part look bigger by 6. So I'm going to go from 0 to 6 for my exponential value. That's how you deal with any number in scientific notation. Whether it's smaller than 1 or greater than 1, it doesn't matter. Whatever you do to the decimal number, you do equal but opposite idea to the exponent number. So obviously this example we're dealing with a number that's much larger than 1. What if we have a number that's smaller than 1, such as that? Once again, you can think of it in exponential notation as being that times 10 to the 0. So now whatever I do to the decimal number here, I got to do the opposite thing to the 0 here. So I'm going to make this 7.4. So I've moved it 1, 2, 3, 4, 5, 6, 7, 8 places. I've made the number look bigger from 0.000 yada 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 7.4 to 7.4. If I make the decimal number look bigger, I'm going to make the exponent look smaller by the same amount. So I went 8. So this is going to go from 0 to negative 8. So I know some teachers say, well, if you move the decimal point to the left, you're making the exponent larger, and so forth. I think just remembering that you have to do the opposite is an easier thing to remember. If you want to learn it some other way, be my guest. And so that makes it easy. Just remembering that one rule makes it easy. So we've just talked about how I convert a decimal number into scientific notation. If I do the opposite, what if I want to go, from the scientific number to the regular decimal number? So if I'm starting off with 9.5 times 10 to the negative 6, Okay, well, -6, I want to take to 0, right? I want to make it look like a normal number. So from -6 to 0, I'm going to make this part look bigger, which means I need to make this part look smaller by the same amount, by 6 places. So 0.00000095, because I've moved it 6 places, 1, 2, 3, 4, 5, 6, times 10 to the 0 is really what I need to do to put that number in decimal form, but remember, we don't typically write that part. But that's the idea that you want to think about. So you can write 0.0 and do it that way. Likewise, if I have a number bigger than, or if I have an exponent that's bigger than 1, so I have 3.8 times 10 to the 4th. Okay, 3.8 times 10 to the 4th. I know this is a number bigger than 1. This is a number smaller than 1. This is bigger than 1. I know that I'm going to move the decimal to the right. I'm going to make the exponent smaller while I make the decimal number bigger by 4. So 38000, 1, 2, 3, 4 places, and then the exponent reduces to times 10 to the 0, which again we know is 1. Okay, so again, you do opposite to the exponent what you've done to the decimal part. This idea comes in handy if you are given a number in non-proper scientific notation. So you have 268.4 times 10 to the 3rd. Okay, if I want to write this in proper scientific notation, how do I do it? Well, proper scientific notation says make it 2.684. Okay, 2.684 means I've moved the decimal from the 8 to the 2, so I made my number look smaller. I need to make my exponent look bigger. By how many places? Well, 2. So instead of 3, it's going to be 5. So there's a really quick way that I can make any number that's in exponential notation proper scientific notation by remembering that rule. Whatever you do to the decimal number, you do equal but opposite to the power of the exponent. So on this organizer, it kind of goes through those ideas. But the other nice thing about this organizer, before you have to do homework where you don't have the answers, you actually have a little bit of practice on the back where you can do practice and then check your answers down here at the bottom. You probably will also have problem sets assigned to you, but that is up to the discretion of your instructor. So there you have scientific notation. Good luck on the practice and on your homework.